Hello, everyone, and welcome to this special conversation. I'm 𝘚𝘦𝘦𝘪𝘯𝘨 alumna of IIT Kharagpur, and today I'm delighted to be speaking with Dr. Sanjay Rana, a renowned geophysicist with over 3 decades of experience in near-surface geophysics. Dr. Rana is hosting an upcoming free webinar on geophysics in archaeology and heritage conservation, and today we'll explore why this topic is so relevant and exciting. Dr. Rana, welcome.
Thank you very much, 𝘚𝘦𝘦𝘪𝘯𝘨. It's absolutely a pleasure to be here.
Dr. Rana, geophysics is often associated with engineering or infrastructure. Why do you think it has become so important for archaeology and heritage conservation today?
That's a very good question to start this conversation. See, archaeology traditionally lies on excavation, which is a powerful tool, but it is also irreversible. Once you excavate, the original context is actually lost forever. Geophysics offers a way to understand what lies beneath without disturbing the ground. So it allows archaeologists and conservators to see buried structures, voids, and earlier construction phases non-invasively. This is the key point. So in today's context of protected monuments and ethical archaeology, this capability has practically become indispensable, where we do not want to disturb the ground which we are trying to investigate.
Non-invasive exploration. That's interesting. So your webinar title uses the phrase seeing without digging. What does that mean in practical terms?
So when we are talking of seeing without digging, we are talking of looking at contrast in physical properties, trying to build an image of what is underground, just like what we are doing in X-ray and ultrasound, if we talk about medical terms. So there we are not doing any incision, we are not doing any cutting, we are not cutting open the body, but we are trying to create an image of what is inside. So same thing we are trying to do. So for example, a stone wall. Now, if there is a buried stone wall, that will conduct electricity very different than the soil. Fired bricks affect the magnetic field. So if there is a fired brick construction down there, we will pick the anomaly in a magnetic survey. Voids will reduce subsurface density, which will be picked up, for example, in microgravity. So by measuring these contrasts using different tools like GPR, like magnetics, like electrical resistivity or microgravity, we can create maps and sections of buried archaeology before excavation or even excavation at all. So that is the strength of using these methods. And when we say seeing without digging.
As long as we are on the topic of geophysical techniques, could you briefly explain which geophysical techniques are commonly used in archaeology and heritage conservation?
Surely. So most the technique of ground penetrating radar, right? So that is something which is most talked about. And this is an excellent method for mapping buried walls, floors, voids with a depth control, of course, right? And GPR has a limited depth penetration, and that depends largely on the ground conductivity. So that point is there. I'm a big advocate of using multiple tools to solve a problem. So GPR, although is most accepted, I always maintain that this should not be the only one. So magnetic surveys, for example, they are very effective for large area mapping of settlements, hearths, kilns, ancient activity zones. Then we come to electrical resistivity imaging, which will help you detect stone structures, because as I said, stones will conduct electricity very different than the soil, tunnels, moisture pathways. Then we come to microgravity, which is basically measuring the change in the density. So it's great for locating cavities beneath monuments. Seismic methods will help assess foundation stiffness and stability. So the real strength comes when these methods are integrated rather than used in isolation. Integration is the key word, because two completely different material can have a physical property which is the same. So if you're just using one method, you might not be able to differentiate between the two. So it's very important to integrate the methods.
So as far as my understanding goes, you've been always a great advocate of the integrated approach when it comes to geophysics. Many heritage professionals today worry a lot about structural safety. How does geophysics help in conservation rather than just discovery?
That's a very important distinction, you can say, between the two. Okay. So many heritage structures fail not because of visible damage, but due to hidden subsurface problems. These can be voids, weak foundations, or moisture ingress. So geophysics allows us to diagnose these issues early in a totally non-invasive manner. Think of it like detecting or ability to detect cancer at stage one rather than waiting for its manifestation and full symptoms. And that too in a totally non-invasive manner. That is without any cut, without any drilling, without any digging. So it supports preventive conservation rather than emergency repair. So when we are talking of geophysics, mostly we are talking of a proactive and preventive kind of a approach. And for engineers and conservators, geophysics becomes a diagnostic tool, not just an exploratory one. So that's where the distinction comes from.
Great. Who would you say will benefit most from attending your webinar?
Well, this is an interdisciplinary webinar. So as we say that, we are going to discuss various topics from archaeology for heritage conservation. So archaeologists, heritage professionals, conservation architects, engineers, planners, researchers, geoscientists, students. I hope all of them will find value. Archaeologists will learn how to reduce blind excavation. Engineers will understand subsurface risks beneath the monuments. The students will see how science and heritage intersect in practice. So I hope these are the segments which will find a lot of value in this.
Dr. Anna, in this day and age, there are many technical talks available online, right? So what makes this webinar different?
That's an interesting question. And see, first of all, most of the webinars which are happening, they are centered around a particular software or a hardware. So this is not a software demo or an instrument focused session. So we are not going to talk about a particular instrument like GPR or a particular demonstration of a software. The emphasis is on concepts, interpretation, ethics, and decision making. So I want participants to understand why and when geophysics should be used in archaeology and conservation, not just how. So it's about thinking differently about the ground as a historical archive. And that is what puts this webinar completely different from generally the material which is available. What is available has been put by concerned manufacturers or software developers, whereas this is coming more as in a form of information sharing. So that's the major difference.
And finally, what would you like to say to someone who is on the fence, who is unsure about whether to register or not?
Well, that's what I said just before this, that it is about understanding the ground and treating the ground as an archive. So if you're involved in archaeology or heritage in any form, this webinar will change how you think about what lies beneath your site or monument. It's a free, non-commercial, and designed to be practical and thought-provoking. And of course, since seats are limited to keep it interactive, I would strongly encourage early registration because we will close the registration once we fill our seats. So we just can't keep it open forever. So I would really urge people to register early for this.
Absolutely. Thank you, Dr. Anna. This has been a fascinating conversation. For those listening, the webinar Seeing Without Digging, Geophysics in Archaeology and Heritage Conservation will be held on 31st January 2026 at 3 p.m. Indian Standard Time. Registration details are available in the description. See you there.
Thank you very much. And I look forward to interacting with participants during this webinar. Let's learn together. Let's learn how to see what lies beneath the ground without actually having to dig. Thank you very much.